This is a demonstration of my Visual Basic 2010 Express OpenGL chart extractor. Why is it OpenGL? Well, it's because in a future iteration of this product, I intend to implement 3D charts, which will allow you to have a z-axis on a chart that you can zoom in on and rotate. But for now, let's focus on the current 2D version of the chart extractor. Here it is. Okay, here you are looking at a 2D chart of coefficient of drag versus Mach numbers for sphere shapes of various sizes, from a musket size one to a cannonball one, and to an Civil War artillery size cannonball ones, and a tank round size one, which doesn't exist. So this software is mainly for aerospace purposes. The round shaped objects have little application in aerospace, but we're using it to test my product, to make sure that it works correctly, because sphere-shaped objects are basic and they produce basic results that are more predictable, and they've been heavily researched. Okay, so here we have multiple graphs in different colors. Now, as I said before, in a future version we'll have a 3D chart that can transform a 2D chart like this into a 3D one by making the red one, say, closer to the screen and the larger values further away from the screen along the z-axis, and then you can do away with the colors. But for now, let's see how this chart extractor works, this 2D chart extractor. Now, first thing you gotta do is you gotta calibrate the software, and to do that, you gotta tell the software where 0, 0 is on the XY plane. So you use these buttons and you position it on 0, 0, and you box the whole chart to the maximum values of X and Y as best as you can. Now, I will add in a feature where you can just drag the box with your mouse, but even after adding that feature in, you'll still need these buttons to sort of do a bit of micro adjustments. Okay, next thing you do is you fill in these boxes, which do nothing at the moment, but later on they will store these values as metadata so that you can reproduce the charts from a file with labels and numbers, and not just the shape of the chart. So the first one, you put in CD, which is the label for the y-axis, right? And the maximum value of 1. Second one, you do the same for the x-axis. You put in Mach number, or just Mach, and the maximum value is 1.6. Then you set the axis, which basically is baby language for calibrating. All right, so we've calibrated it, so we have a calibrated scanning chart now in this tab. This over here is an uncalibrated scanning chart, which will match the size of this movable scanning box, right? So if you change the size of the movable scanning box, that changes, but this does not. Okay, so let's get the red chart, because it's the easiest chart to get. We'll do baby steps. We'll do the easy ones first. Red. So to get the values of charts from publications, you have two choices. You can do it the hard way, with pen and paper with a protractor on a table, or you can do it my much faster computational method, which saves a lot of time, relatively speaking. I mean it's this is slow as well, but it's a lot faster than doing it with pen and paper. All right, so first thing we gotta do is okay, I've skipped a step. We have to get a general sense of what the pixel values are in the graph, okay? And to do that, you go over here. Now don't panic, all of these will be invisible in the final product. We're only looking at this, so all this telemetry stuff will be deleted, gone. I only use them to debug the program to make sure that it works properly. So only this will remain. Now these three values is what we're looking at. These are pixel values, so red, green, blue. Now I've actually, as you can see, it's really hard to exactly click on the graph, and I've obviously missed and hit the background, which is white, which is 255, 255, 255, right, for all colors. So you have to micro adjust a little bit with these buttons, move the movable box up, so that the bottom left corner of it will hit the pixel that you want. And here we go. Now we have something that's not background. It's red and green 0 and blue 0, right? So it's got the maximum value for red and a minimum value for green and blue. Now, should I set up my scanner to only look for pixels with these values? No, because if you move it a little bit more, you'll see that within that chart you'll have other values that are a little bit different, okay? Like red is still 255, but you got green and blue as 69. So what you gotta do is you gotta set up with the software to have a little bit of tolerance for slight variations. Okay, let's resize this again. Okay, so what we'll do is we'll set now this is what we call the maximum pixel value with all these scroll bars for red, green and blue, and the bottom set is called the minimum pixel value. So what I'm going to do is I'm going to set it up so that the scanner is only going to consider values of red within this range, within the top half of the whiter range, and it's only going to include green and blue if they're on the darker half. All right, so that's a fairly wide range to make sure that if anything is a little bit red, it's red. So let's scan the chart. Now this is what I meant when I said it is still a slow process, because scanning is a computationally intensive process, but it's a lot faster than doing this on pen and paper, because not only does it automatically get the values for you, but it can also save it into a text file for you. And because scanning is an computationally intensive process, you only want to include the area on the picture that has the chart more or less. All right, you don't want to unnecessarily scan outside the relevant area, because it's going to take more time. Now, while this is scanning away, if you look over here, you can see that some of these charts, they're overlapping, and their original colors disappear as other charts dominate. For example, this light blue one, I would hate to have to do that one, because it gets lost over here somewhere. And now, Now there are ways to, now there are procedures to fix that problem, and I'll show you that right after this is done. What you can do is you can just scan a relevant area first for where the blue chart is visible, and then you can scan the other parts where other colors dominate and extract those other colors, such as the red, and include them in the blue chart. Oh, what's happened? It's done. Okay, so that's our red. Now this is different. Now on the left here, it's calibrated to the XY axis. If you look over here, this picture box is the exact same size as the calibrated box. It's the exact same size as the axis, right, of X and Y. It's like we cut this out and we put it in here. On the right, on the other hand, is the movable scanning area only. So our final product is really this. All the X and Y values of this red chart are the correct values for coefficient of drag and Mach values according to this axis. Now let's pretend we're done with red. We've saved this shape into a text file, ready to be used in an aerospace program. And now we want to do the really tough sky blue chart, violet or whatever. Okay, let's move it down a little bit. Well, actually, let's have a look at the colors first. So that's the background color. Okay, we have 0 value for red and maximum values for green and blue. It's like an inversion of the red that we did before. It's like no red club, basically. But as you can see, there's a slight variation. It's not always 0 values for red. It can be 26 as well, right? And then now it's 36 for red. But it looks like green and blue is always 255, and I'm pretty confident it stays at 255. So what I'll do is for this one, I'm going to set it up so that, well, first of all, I have to recalibrate, and later on I'll have a recalibrate button. But for now, the only way to clear our previous work is to do this procedure again. That is to calibrate the axis, and that'll clear our previous work. Set axis, so you can see it's blank now. That should be blank too, but I'll fix that later. I need to make it so that that clears too when I press that button. All right. So let's see if we can extract light blue. Now once again, it's a computationally intensive process, and on top of that, you want to exclude any content that's going to fool the scanner into thinking that it's found the chart when it hasn't, right? Such as the words. So really, let's see if I can move it up a little bit. There we go. Resize that. Okay. Now, as I said, it's going to be an inversion of red. So the maximum value ideally would be like this. However, the minimum value, I'm pretty confident the green and the blue are not going to move at all. But I'm going to give a little tolerance for red. Okay. So let's say 68. I'm going to scan, so it's going to scan between these 2 pixel values. Scan chart. Okay, well, that's embarrassing. What just happened? Nothing showed up. Okay, so, maybe I should give a little tolerance for the green and the blue. Let's see what happens if I do that. Let's scan again. Oh dear, I know what I've done wrong. It's the red value. I gotta switch them between min and max. Okay. No wonder it didn't work. I've gotta swap these two values around. So, see, the bottom one is minimum, and the top red RGB pixel is maximum. But what I've done is I've set the minimum to maximum and the maximum to minimum, so obviously it's not going to work. It's just confuse the program. What I should do is add code to make sure that you can never have this situation, and if you do, the program will alert you. So here we go. That must always be greater than its counterpart at the bottom. Okay. All right, let's scan again. There you go. I can tell something's different already. It's doing certain things a lot quicker. There we go. But as you can see, there's some gaps. All right. But this is the calibrated version. So to fill in those gaps, you have to scan those gaps. And try and detect violet by doing all this stuff and exploring the pixel colors and experimenting with them. But I don't have time to do that right now, so let's just fill in the red bit because we've done that before. So we're gonna complete the top portion with the red. So I'll add in code so that when you move these scroll bars, it'll drag the bottom ones as well if it's above it, if the values are above it. All right, so that you can never have an inversion again. Now, as you recall, red, the configuration for detecting red was like this. So we already have our light blue portion, and we're going to add in a red. So we're going to have two different colors in the same chart. Scan away. There it is. So we got the red here and the light blue here and a really big gap here. That really big gap looks like it's black. Should be able to do that in the time I have left for this video. Let's do black with some tolerance. That should do it. Yeah. Did not pick it up. I wonder why. What's in there? Oh, red, green, so there's, oh, okay, so there's more green. Green, blue, there's some, yeah, it's pretty mixed up in there. You know what I could do? I could add another button here, and what it'll do is it'll scan everything in the box that's not white. So whatever it is that's in there will show up in there, and I've done that before when I'm stuck. So I'll add a functionality to exclude white, and when it hits anything that's not white, it'll move on to the next column and add whatever value it is in the gap. So that's basically how my program works right now. Obviously, it's a work in progress. And once this multicolored graph is complete, you can save it and just throw away the color values and just save the X and Y values into your file with the metadata here.